These massive, vibrant green circles scattered across the Saudi Arabian desert are a feat of high-tech agricultural engineering. To grow crops in one of the driest places on Earth, farmers siphon ancient fresh water trapped a kilometer underground. But monoculture farming lacks biological complexity to sustain the soil. Rare rainfall simply runs off or evaporates, instead of refilling the shrinking aquifer. Experts estimate these pumps will run dry in about 50 years. At that point, the artificial oasis will vanish, and sand will reclaim the land. Brute forcing nature through unsustainable extraction creates a temporary mirage, not a permanent cure for the desert. This crisis is accelerating globally. The Gobi Desert devours roughly 6,000 square kilometers of grassland every year, swallowing entire villages and forcing tens of thousands of people to flee. To the west, the Aral Sea has been turned into a wasteland. Decades of aggressive industrial farming and topsoil degradation have drained the life from a region that was once fertile and productive. Mapping the hot zones of desertification across Southeast Asia, the Middle East, and Africa reveals a process that puts 1 billion human livelihoods at risk. By mid-century, 25% of the world's soil is projected to be degraded. If extraction and brute force can't solve this crisis, what actually works to stop the sand from swallowing the world? The Al Baida project in Saudi Arabia utilizes a counterintuitive approach. Instead of pulling water up from the earth, they engineered the landscape to catch the rare, violent flash floods that fall from the sky. Using terraces and kilometers of ditches, methods pioneered by the Incas hundreds of years ago, they catch and slow down the rushing floodwaters, forcing the liquid to sink into the dry earth. Slowing the water physically allows native grasses and shrubs to establish roots. Once this biology is in place, the plants themselves act as a sponge, slowing the water down ecologically during the next flood. This system survived its ultimate stress test when the region suffered a 30-month drought. The native flora and the returning wildlife survived the entire dry spell without a single drop of artificial irrigation. Restoration begins by repairing the soil's natural capacity to hold water, turning rare rainfall into a sustainable, long-term resource. But even local success seems small compared to the Sahara, which is currently expanding by almost 48 kilometers every year. Stopping a desert this large requires a massive technological intervention. Scientists have proposed a hypothesis to alter the regional climate, covering 1/5 of the Sahara in black solar panels and wind turbines. The solar panels absorb intense heat, warming the air directly above them and forcing moisture-laden air upward. As that air reaches high, low-pressure altitudes, it cools and condenses into rain, falling back down and potentially increasing vegetation by 20%. Despite the scientific potential, the estimated $20 trillion price tag and the logistical hurdles of maintaining such a grid make the project functionally impossible. While we can theoretically manipulate regional weather, the astronomical financial cost prevents it from being a realistic global cure. The world's most successful restoration project, China's Kubuqi reforestation operation, is currently pushing back the desert line by balancing technology with economics. Speed is the key breakthrough here. Workers use specialized water jets to blast a hole in the sand and instantly plant a cutting. This process takes only 10 seconds per tree. To protect these seedlings from the wind, farmers arrange grids of straw bales around the plants, giving the roots time to anchor into the dunes. Market economics sustain the operation. Farmers plant licorice and other climate-resilient herbs to supply the highly lucrative traditional Chinese medicine market, creating a self-funding restoration cycle. This has triggered cascading regional benefits. Wildlife has returned to the desert, and the new green barrier has drastically reduced air pollution caused by sandstorms in Beijing. Reversing desertification at scale requires this precise integration of technological speed, ecological protection, and market demand. Human ingenuity can turn dust back into life, whether through ancient irrigation, futuristic water jet planters, or theoretical weather-altering solar grids. However, the staggering amount of capital and labor required to fix damaged land means we can never artificially resurrect every desertified acre. The only viable strategy to stop the spreading deserts is triage, curbing global warming and halting the overgrazing and deforestation that destroy our existing healthy topsoil. Look at the sharp line between the sand and the human-maintained land. It represents a fragile boundary between survival and ecological collapse. Maintaining our healthy soil is the fundamental, non-negotiable foundation for human